All right, so let's look at it again. Some more examples of this. So what we have is the limit as x approaches pi over 4 of tangent x equals 1. Suppose we want tangent x to be within 0.2 of 1. So right there. How far from pi over 4 should we choose x? So again, let's rewrite these. So if we have the limit as x approaches pi over 4 of tangent x equals 1, then modifying this, we get tangent x minus 1 is less than epsilon, right? That's our y's. And we get x minus pi over 4 is less than delta. So if we go back and read this, we know that our tangent x has a distance from 1 that is less than epsilon. So it says, suppose we want tangent x to be within 0.2 of 1. They're saying here that our epsilon is 0.2. So we know that this is 0.2. And now it's saying how far from pi over 4 should we choose our x. So now they're asking us to find delta. So we're given our 1 here. And let's draw our tangent graph. It looks just like this. So at pi over 4, we know it's 1. Okay. So we know our epsilon is 0.2. So the distance from 1 is 0.2 that way. So 1.2. And it's negative 0.2 this way. So 0.8. And then that is our epsilon. So what we're looking to do is trace this back and find our possible delta, which would be the best delta that we need. So we take our 0.8 and we plug it into our function. So our y value here is tangent x. And again, that's our first y, and that's our second. So we can plug it in. So the 1.2 would go, the 1.2 will go here, and the 0.8 will go here. So 1.2 equals tangent x. So we use the calculator to find the inverse tangent of 1.2 to equal x. So inverse tangent of 1.2, and we get 0.8761. And then now we do the other one. So let's park that on there, 0.8761, and let's find the next one. So 0.8 would equal tangent x. So again, inverse tangent of 0.8 is x. We plug it in. So second inverse tangent of 0.8, hit enter. We get 0.6747. All right, and we can also do this another way. If you graph it, so we're going to plug in our y values that we have. We have tangent x here, and we're going to also plug in 1.2 and 0.8. If you want to plug in 1 as well, you can. That would give us our center. But you want to think about our tangent. It's going to go from 0 to pi over 2 until it gets that undefined. So we go to our window, and we go 0, and then for the second one, you put in pi divided by 2. And then we want to make sure that we get our y value. So it needs to go up to 1.2. So I'm going to start with 0. And I'm going to put my y max at 2. And then hit graph. And it'll give us this nice little window that we have. And it'll draw those 0.8s and the 1.2 for us. So there's the 1.2. There's the 0.8. And so that's where it's intersecting. So if we go second, calc, intersect, and select that one with the red one, and then whatever for your guess, you'll see it says 0.8761. That's the one we wanted. So we write that down. So you can see that that translated down would be right here. And then we do it again. Second calc, intersect, this time with the blue and the black. And so you just scroll up until it has the black. There it is. Hit enter, and it says it's 0.6747. So that's another way of doing it. You just graph the function 2x, which is our one that we're looking for, and the 1.2 and the 0.8. And we get these values. Now we need to find out which one is our delta. So not either of these is, but the distance. So remember, we plug them in. And we're going to find out what that is. And then we're also going to plug in the other one. And so we just bring back up our calculator. We've already got those values in there. So we're just going to take each of them and subtract pi over 4 from them. So we want to find out how far it is from pi over 4. So that one is 0.0907, 0.0907. And then we do the other one. So let's scroll back up and grab it. Minus second pi divided by 4. Hit enter. And it's negative 0.1, but the absolute value turns it back positive. So 0.1107. And so that means our delta has to be the smaller of the two. And here's the reason why. If I were to go, so if we plug these on here, this is 0.6747. That's that one. So the first one, the 0.876, this one has a distance of 0.0907. So we go this way, and it's 0.0907. And this one is 0.1107. Well, if I went that same 0.1107 this direction, right? And so if I took that one all the way over here, 0.1107, I would end up here. And if I follow that up and hit my graph and then move over, you can see that I am actually now more than 0.2 away. And we want our tangent x to be within 0.2 of 1. So you're going to pick the smaller so that when you go to the left and to the right, you're within this little region. So you're always picking the smaller. It looks like this. So I've exaggerated it a little bit, and this is an x squared to give you the idea. But look at my delta, and so you can see if I go to the smaller one, right there, I'm trying to get it to work right there, you can see that we're within. Even though it's red, I have to go a little bit more. A little bit smaller. Here. Put in 0.4. An extra delta there. Okay. So you can see that if I pick the smaller distance, they're both within the region. But if I pick the other one, right there, you can see by going 0.6 units to the left, we're fine. We're within the region. That's fine. It's 2 units away from 4. But going 0.6 this direction, we're way outside, and it's not going to match. So you're always going to be picking the smaller of the two that make it sure that you are within that region. So you always pick the one that keeps you within the region, both sides. So in this case, it's the smaller. So there you go. So how far from pi over 4 should we choose the x? Oops. 0.0907, and that would keep us within that region. All right, so let's try another one in the next video. We're going to try another one.